All right, in this video, we want to discuss some properties of logarithms before we jump into the next couple of sections. Okay, so for our properties of logarithms, here is what we know. This is what we're going to be working with. Now, again, this should be a review. We should have already seen all this stuff back from college algebra, so let's just go ahead and discuss it briefly now. So, for x, y, and a greater than 0, and a not equal to 1, here are the properties that we have. So log base a of the product xy is equal to the sum of the logs, log base a of x plus log base a of y. So if you have a product inside of a logarithm, you can split that up as the sum of two separate logs, making sure you keep the same base. Somewhat similar to that, if you have a quotient inside, the quotient turns into a difference. Okay? And then the third one is log base a of x to some power r is equal to r times log base a of x. So basically what you're able to do is you can bring this power out to the front. Now, this gets used a little bit more often when we're talking about solving equations and we have to apply logarithms. Okay. Now, for these logarithms, most of the time there's going to be a base indicated, like I have a little subscript of a, but there are two logarithms that we see quite often. So I want to mention those, that way when you see them, you know what I'm talking about. So there's the common log versus the natural log. The common log is written as, let's say, log of x. So even though there is no base that is explicitly written, this is understood to be log base 10 of x. And there are a lot of things in the real world where we use the common logarithm. We're talking about, say, decimals. We're talking about magnitude of earthquakes. A lot of times we're talking about logarithms, the common log. Same thing with pH balance. The natural log, we'll see it like this. Natural log of x has an understood base of e. Now, whenever I do natural log, and again, this is it's a lowercase l and a lowercase n. I do it in cursive. I don't do that for regular log. I don't really know why, but that's how I do my natural log. Now, if you ever forget what's what, take a look at our graphing calculator, and you'll see that here where you see the log button, just above it in blue you see 10 to the x. So that tells you that the base for the common log is 10. The base for natural log, ln, you see there's e up here. So that's kind of an indication that that's what the base is going to be. So again, just a quick little thing to check if you ever forget which is which. Excuse me. Now, with these logarithms, we have a statement about the theorem on inverses. Remember that the logarithm is the inverse of the exponential. So that would lead us to this. Log base a of a to the x is x. So if the base of the log matches with the base of the expression inside the log, then it's as though they reduce away and you're left with just x. Or if you have a raised to log base a of x, that will also lead you to just having x. So if the base of the exponential and the base of the logarithm are the same, you're going to get whatever's left on the inside. And we're going to run through some examples of that here in just a moment. And the last guy, which I think is a pretty big guy, is very useful. It's the change of base theorem. Change of base theorem. Now, what this allows us to do, it allows us to rewrite a logarithm to any base that we want. So, log base a of b may be rewritten as log base c of b over log base c of a. The key thing here is that whatever base you choose, it has to be the same. You can't say, you know, I want to make the numerator log base 2 and I want to make the denominator log base 5. It doesn't work that way. Now, so you can choose whatever base you want, and there are some problems that we're going to see where it definitely helps to choose a base, because if you see that here, if A and B have a base that's common, maybe you rewrite it with that common base. Some problems, you're never going to find a common base. And so it's helpful when we have the graphing calculator to just throw it in there. So we need to make sure we can type it correctly. So we would do something like this. Say common log of B over common log of A. Or you could do natural log of B over natural log of A. And you'll find that whether you use common log or natural log, when you were doing this change of base theorem, you're going to get the same result. Okay, so now that we have these major pieces of information out of the way, let's then take some time and work through some problems. So that's going to be in the next video, so stick around.